All right, so here we're going to learn about Gauss-Jordan elimination. We need to write the augmented matrix for the system. We've talked about doing that in the previous section. And we're going to use the matrix and row operations to simplify the matrix to row equivalent matrix in row echelon form, with ones down the main diagonal from upper left to lower right, and zeros below the ones in the first and second columns. So, first goal of 1 here. This is a 3 by 3. We've done 2 by 2s now, or like a 2 system. Now we're going to do, or a 2 equation system. Now we're going to do a 3. So 1 here, 0, 0, then a 1 here, and then a 0 below it, and then the last one there. And then you can, just like we've done before, put them back into the equation in order to solve them. All right, so I've kind of written on the handout what our goals are. First number has to be the 1, the 2 zeros below it, then the 1, a 0 below it, and a 1. We'll write the system of 2 linear equations corresponding to the matrix and use back substitution to find the solutions. There is more than one way to reach your goal. It just depends on which operations you choose to do and the order you choose to do them in. You can get inconsistent and dependent systems, and you can have a system with no solution. So this one, like we talked about before, this would be no solution because we end up with 0 equal to 5, and that doesn't make any sense. So this would be a no solution because of the false statement. This one is a system with infinitely many solutions. We've seen this before. Not necessarily in this type of situation, but when we've done just solving systems without matrices, with addition, and we found something that looked like this. So 0 equals to 0, that is a true statement. So then you would drop that row and you would write it like this. And then you will solve for x and y in terms of z. So you would solve y by adding the 10z over and get 10z minus 1. And then the x you would solve by adding the y over and the 2z and get, and then you also have to plug in y as 10z minus 1. You have to solve it in there by where it's only in terms of z. So you have to plug the y into that one as well. You'll end up with 12z plus 1. So when you solve it all in there. So those are the way that the answer would look. So let's go do our first example. And we're going to do it step by step. So example 1. We're going to use the matrices and Gauss elimination to solve the system. And here is our system. X plus 2y plus z equals 2. I will put a line in my z so you can tell the difference between when I write a z and when I write a 2. Negative 2x minus y plus 2z equals 5. And x plus 3y minus 2z equals negative 8. So the first thing we need to do is write our matrix. 1, 2, 1, line 2, negative 2, negative 1, 2, and 5, and 1, 3, negative 2, and negative 8. Make sure that you bring over the negative signs from your system. All right, so the first row has to be a number 1. Oh, we've got that. Second row has to be 0. So how can I get a negative 2 to be a 0? Well, I need to add 2. So I'm going to multiply row 1 by 2. So 2 times row 1, and then add it to row 2 to get our new row 2. So 2 times row 1 will get us 2 times 1, 2 times 2, 2 times 1, and 2 times 2. Gets us 2, 4, 2, and 4. And then we have to add row 2. Negative 2, negative 1, 2, and 5. We add those, we get 0, 3, 4, and 9. So this is our new matrix. Row 1 is still the same, even though we used it. Row 2 is now 0, 3, 4, and 9, and row 3 is the same. All right, now our next goal is to get this to be a 0. So how do we get 1 to be a 0? We need to subtract 1. So what I need to do is multiply the first row by negative 1 and then add it to row 3. So negative 1 times row 1 plus row 3 will get us our new row 3. So negative 1 times row 1 will be negative 1 times 1, negative 1 times 2, negative 1 times 1, and negative 1 times 2. That gets us negative 1, negative 2, negative 1, and negative 2. And then we will add our row 3, which is 1, 3, negative 2, and negative 8. Negative 1 plus 1 will get us 0. Negative 2 plus 3 will get us 1. Negative 1 minus 2 is negative 3. And negative 2 minus 8 is negative 10. Rewrite the matrix. Row 1 did not change. Row 2 did not change. But row 3 is now 0, 1, negative 3, and negative 10. All right, now our next goal is that we need to have the second number in row 2 be a 1. However, row 3 already has a 1 in that position. So what we can do is we can switch the rows. So we can switch row 2 with row 3 because they're just equations, right? So we don't have to do anything else. So our matrix will now be 1, 2, 1, 2, because row 1 didn't change. 0, 3, oops, not 0, 3, 0, 1, so sorry. 0, 1, negative 3, negative 10, and then 0, 3, 4, and 9. So what we did is just switched row 2 and row 3 around. Nothing else. We didn't have to do any math. All right, now what we need is this to be a 0. So how do I get this to be a 0? Well, I need to subtract 3. I can use row 2. I can't use row 1 because if I do, when I add whatever I do to 0, that won't still be a 0. So I can use row 2. Row 2, if I multiply it by negative 3 and add it to this, I will get a 0 for that term. So negative 3 times row 2 plus row 3 will get us our new row 3. All right, so negative 3 times row 2 would be negative 3 times 0, negative 3 times 1, negative 3 times negative 3, and negative 3 times negative 10. That will get us 0, negative 3, negative 3 times negative 3 will get us a 9, and negative 3 times negative 10 will get us 30. And then we'll add row 3. Row 3 is 0, 3, 4, and 9. That gets us 0, 0, 13, and 39. And rewrite the matrix. So 1, 2, 1, 2, 0, 1, negative 3, negative 10, and our new row 3 is 0, 0, 13, 39. All right, now our next goal is that this needs to be a 1. So how do I get 13 to be a 1? Well, I need to divide by 13. But if you recall, we don't divide. We're going to multiply by 1 over 13. So our next operations that we're going to do will be 1 over 13 times row 3 will get us our new row 3. So we'll have 1 over 13 times 0, 1 over 13 times 0, 1 over 13 times 13, and 1 over 13 times 39. Well, this will be 0, 0, we'll get 1. 39 divided by 13 will get us 3. Rewrite the matrix. So 1, 2, 1, and 2, 0, 1, negative 3, negative 10, 0, 0, 1, and 3. All right, we've got our goal of 1, 0, 0, 1, 0, and 1, which is awesome. So now what we need to do is rewrite our system. So our system will be x plus 2y plus z equals 2. Y minus 3z equals negative 10. And z is equal to 3. So now that we know what z is, we can solve for the rest of our variables. So first we'll sub z equals 3 into this equation. So we have y minus 3 times 3 equal to negative 10. Y minus 9 equals negative 10. Add the 9 over, and we get y is equal to negative 1. Now what we'll do is sub z equals 3 and y equals negative 1 into our first equation. So we'll have x plus 2 times negative 1 plus 3 is equal to 2. So x minus 2 plus 3 equals 2. Well, negative 2 plus 3 will be 1. So x plus 1 equals 2. Subtract the 1, and we get x equal to 1. So this time, instead of an ordered pair, we have an ordered triple. We have x is equal to 1, y equals negative 1, and our z is equal to 3. And again, you can check it back into your original system to make sure that it works. So that is a 3 by 3. All right, our next example is we have a theater sells adult tickets for $18 and children tickets for $9, with a total of 517 tickets were sold, totaling 6,219. How many of each type of ticket were sold? We've done this problem in the last section, but this time, or not in the last one, maybe it's the one before, we did it by addition, and now we're going to do it by matrices. So this will be example 2. So if you recall, we have to set up our system because we're not told what the equations are. And if you remember, we had adult plus children will be equal to the total. And we have two different things. First, we just have the tickets. We have the number of tickets. And then we're going to have the cost of the tickets. So you can use any variable you want. I typically use x and y because that's the ones the students feel most comfortable. So x plus y equals the total number of tickets was 517. And the cost was 18 for adults and 9 for children will get us the total, the proceeds that they gained. So this is our system So now what we want to do is take the system and write it as a matrix. So our matrix will be 1, 1, 5, 17, and 18, 9, and 62, 19. Now, our first goal, we need a 1 up here. Got that. Now what we need is a 0 right here. So how do we get 18 to become 0? Well, we need to subtract 18. So that means we are going to have negative 18 times row 1 plus our row 2 equals our new row 2. It's always awesome when the first one's already solved for us. We don't have to do anything about it. All right, so negative 18 times row 1 will get us negative 18 times 1, negative 18 times 1, and negative 18 times 517. So that gets us negative 18, and negative 9,306. Now we'll add our row 2 of 18, 9, and 62, 19. Gets us 0, negative 9, and negative 3,087. Rewrite your matrix. So row 1 did not change, we just used it. And row 2 is now 0, negative 9, negative 3,087. So now we need negative 9 to become a 1. So how do we get negative 9 to be a 1? Well, we can just divide by negative 9. But we don't divide, we have to multiply by 1 over the negative 9, or negative 1/9. So we'll have negative 1/9 times row 2. So now we'll have negative 1/9 times 0, negative 1/9 times negative 9, and negative 1/9 times negative 3,087. That'll get us 0, 1, and 343. And we rewrite our matrix. So this will get us, still row 1 is the same, and row 2 is 0, 1, 343. Now, if they ask you to do reduced echelon form means that they want it where it's all zeros at the top as well. They don't want it where it's just like this. They want that all zeros right there. So I'm going to show you how to do the reduced row form, because in your homework you're going to see that. So now I need to get this number right here on this one, because it's just the 2 by 2. I need this just to be a 0. We could, if we didn't have to do the reduced row echelon form, we could just go back and solve this like we did. This would be y equals 343. Plug that into our system of x plus y equals 517 and get it. But I want you to know how to do this last part. All right, so in order, I need to keep this handy because we're still using it. So to get this to be a 0, I need to use my row 2 and add it to row 1. Because anything times 0 is still going to be 0 when I add it. It won't change it. So to get this to be 0, I need to subtract 1. So I'm going to do negative 1 times row 2 plus row 1 will equal my new row 1. And you only have to do this if they want it in reduced echelon form. So negative 1 times row 2 will get us negative 1 times 0, negative 1 times 1, and negative 1 times 343. So that will get us, that will get us 0, negative 1, and negative 343. And then we will add this to row 1. And row 1 is 1, 1, and 517. So that keeps the 1, this becomes 0, and 517 minus 343 is 174. Rewrite the matrix. Row 1 is now 1, 0, 174, and row 2 is 0, 1, 343. And just so you know, this is the reduced row form. It's reduced echelon row form, but that way you know like why we did that. Otherwise, we could still solve with that. But I want you to know what you need to do to get there. All right, now that we have it in that way, our system becomes a little bit more simpler. If we had written this one like I discussed, this would be x plus y equals 517, and this would be y equals 343. But this system, when you write it off of here, our system will be x equals 174 and y equals 343. That's the system, because there are no y's on that one, and there's no x's, and it's already solved, not sold. So this tells us we have 174 for adult tickets, and we have 343 for children tickets. So we don't have to do any math after that because there's no plugging in. All right, and that would be your answer. All right, so now we have example 3. And we're just going to write the solution. Just writing the solution for this. So if we have a matrix that is 1, 0, 0, 2, 0, 1, 0, negative 3, 0, 0, 1, 4, if that is, and now this would be in reduced row echelon because it has zeros on the top part. This tells us that our system is x equals 2, y equals negative 3, and z equals 4 because we have a third variable. But that's not the solution. That would be the system, right? That would be the system of equations that are left. The answer would be 2, negative 3, and 4. That, again, you have to write it in an order triple. On this problem, I didn't because I need to clarify these were the adult, those were the children.